Sensitive earth fault is the next element in our series that we need to cover. And SEF is commonly used when you have an isolated neutral, or you have compensated neutral networks, or on NER or solidly earth networks where you have safety considerations, or you'd like to improve your ability to protect against fires. So SEF, although it doesn't have quite as many elements as the other ones that we've already covered off beforehand, it's got a forward and a reverse one. But what it does have is access to all of this additional directional protection configuration stuff below. Now, we've also done a webinar on the SEF and high-resolution SEF protection, which is the ability to use auto reclosers to detect down to 200 milliamps of primary current, mainly for the purposes of safety and for fire mitigation. So if you're interested in that, please get in contact with us and we can share that content with you to be able to cover off the technical reasons why you would want to do that, and also more specifically, how do you actually implement that within a network context. But from a configurations perspective, it's a fairly simple element to deal with because you've got far less elements in the whole series. You have a forward and a reverse element here. You can configure how many trips you want to lock out, and you can also decide whether you want to polarize any of these particular elements individually. So you can have one tripping time for the forward and a different tripping time for the reverse. Now, by default, you can use this conventional directional element calculation, which is really a comparison between the zero sequence voltage and the zero sequence current, and then also what the definition of the operation should be if you can't detect what the direction is, which is a plausible situation at very low fault currents. And likewise, what happens if during a fault you get a change in the direction? Do you lock onto the first thing that you saw, or do you allow the elements to separately operate and time out based on how much time is accumulated in the different directions, either forward and reverse, which is dynamic? The last consideration is this advanced polarization detection, which is similar to the earth fault configuration, except that you have access to this additional polarization parameter. So what that does is really give you access to what metric protection. So if you use iron cos theta, what you are doing is you are now acting only on the resistive component of the current, as defined as the angle between the neutral voltage and the measured current. So you're acting only on that resistive component, which means that the way that the SEF elements act changes completely. When you are using just the normal or the conventional directional element configuration, you're acting on the magnitude. But as soon as you introduce this cos phi method into the element, you're actually working on only that resistive component. So for example, what might be 15 amps at 88 degrees becomes less than 500 milliamps of operating current. So it's just important to know the different ways that those two things operate, and if you are using a compensated neutral network or a isolated neutral, then this is going to be the functionality that you need to use in order to be able to get the kind of response that you're looking for. Likewise, once you've actually configured that operation there, setting the currents and setting the trip times is fairly simple. You've got less parameters than what you do with the other curves, as it's always definite time for SEF. So you can just go ahead, set those configuration elements. We might set that to 4 seconds, 5 amps, with a reset time of 0.05. And you can do that for both the forward and reverse trip. And that's it. That is how you configure SEF protection inside a NOJA Power RC10 or RC20 controller using our CMS software.